Hey guys, thought I'd take advantage of my little bit of free time waiting for the doctor here. So anyways, let's do another video on composite functions. And so let's say I'm given, as you can see, f of x, that's a linear equation, right? And here g of x is a cubic or cube equation, it's a 3-power equation, right? Well, if they want f of g of x, what that means is I'm going to take g of x and literally put it inside of f. Think of inside out, okay? And so I'm going to take g of x, and I'm literally, so basically I'll just show my work and then finish it up. So I'm literally going to put that inside, as you can see, of f. So if f is 9 minus 8x, notice I have 9 minus 8. X is now the g of x. So as you can see, finishing it up, f of g of x is just simply 9 minus 8x cubed. Now, let's do g of f of x. What that means is f now goes inside of g. So I'm literally going to take f now, here's f, and I'm going to put it inside of g. If g is x cubed, now notice I have that f function cubed. Now, because unless you're going to use, and bottom line is you're just going to leave it like that, okay? Because the only way you could do this or simplify or expand it, let's say, is use binomial theorem. They're not going to expect you to do that. So g of f of x is therefore simply 9 minus 8x cubed. Now what about f of f? Well, f of f means I'm literally going to take f and put it inside itself. So I'm going to take f, here's f, and notice I'm going to put it inside of f. So notice f is 9 minus 8x, but x is now function f. Now this one we can clean up a little bit. We have 9. Let's distribute that minus with the 8. So minus 72 plus 64x. 9 minus 72 is negative 63 plus 64x. So this right here is f of x. Now, let's say your teacher asks about the domain of your new composite function. Remember, that just means what values x can be. And in this case, if it's linear, I can put in any number I want. So you would say all real numbers, basically. Usually they use that fancy curvy R for all real numbers. Or in interval notation, we would say negative infinity to positive infinity. In other words, any number works. If we were to go back to right here, g of f of x, this is a cube function. It's an odd power function, which means I could put in anything there for x and cube it, could I not? It doesn't matter if this in here ends up being a negative or positive. When I cube it, it's going to come out. It's going to work. There's no error. There's nothing worried, like you're normally worried about dividing by 0, for example, right? So this one, again, is all real numbers. And finally, f of g is another slightly different form of cube function. Again, that one's going to also be all real numbers as well. One of the only situations, again, where you won't have all real numbers is if the function is something sort of like this, where you have the potential of dividing by a 0. In other words, x cannot be 5 there, okay? So hopefully you understand that as well. The other thing I wanted to point out before I end my video is notice how f of g of x is different than g of f of x. That's going to happen most of the time, guys, okay? It's very rare that you can do a function on another function and then reverse it and expect the same result. And the only time that usually happens is when they're inverses of each other for the most part. And you'll find that through experience and time that out. So anyways, guys, hopefully this video helps you a little bit more on composite functions. I'll see you around.